Hi everyone, I continue on the lesson to finish topic 12. We have a question here. A solution is made up by adding this many gram of NaCl and topping it up to 225 milliliter with water. When it says topping it up to means we are talking about the whole solution. So the whole solution is 225 milliliter, and the solute which is added is NaCl 32 gram. So it's asking what is the percent of W over V. So you can find the answer here. So it's everything is ready for you for this part, because you need to do you need to know the part by weight and total by volume, and you have it. Okay, so it says this one. Okay, so I can do, so part or the solute must be in weight, which I have it, and also the total solution must be in volume, which I have it. So it is 32.0 gram over 225 milliliter. Okay, and when I find the answer is 0.142 forever, which I can round it to, because I have three significant digit. I have three significant digit. I can round to three significant digit, so I can just say it is 0.142 forever, and then I underline that, then I check that it is almost 0.142. Okay, but what does this mean in terms of percentage? In terms of percentage, when I say I have percent, when I say I have percent W, means I have, for example, then so how many gram, for example, the number of gram, okay, for the or the unit of weight, whatever is unit of weight, over 100 unit of volume, for example 100 milliliter, for example. Okay, I need to see that. Okay, so when I see this, it is 0.142 means 14.2 over 100, so it's 14.2 gram milliliter. When you see this, then you can say it's 14.2%, okay, W over V. Okay, so that W by V. So the top is weight and the bottom is milliliter. The top is the part that is added, the bottom is the total solution. So for the next step, you need to know V by V, so just V up and V down. So you don't need to go back and start from beginning. You can use part A. What is part A? So part A is 14.2 forever percent for W over V. What's the reason I use bar top of 2? Because I don't want to use rounded number. If I use my rounded number, means I am rounding and rounding and rounding for each step, and I don't want that. So if I want to use answer from part A, I have to use the number which is not rounded. Okay, so that's that. So for the denominator, I'm fine because it's V, but for the top it's W weight, so I have to change that. Okay, so it's this one. So I have to see, okay, so I have to say it is 14.2 forever gram over 100 milliliter of solution. This is the meaning. This is the meaning of percent. Okay, so multiple. Okay, so do I do anything for denominator? No, I just do for top. What should I do for top? I have to go from gram to milliliter. How can I do that? Density. Okay, so I want to cancel gram, so it's 2.16 gram NaCl. Okay, 1 milliliter NaCl. Okay, so then I can cancel this and this, and what is left? This and this and this and this. So the answer is The answer is 6.5843. So I can keep 100 here because then I can say this is percent. I can make it easier for myself. Okay, so here I have three significant digit. The 14.2 forever has many significant digits, so I just consider three significant digits, so I underline that, check that. So it is so milliliter of NaCl and milliliter of solution. Okay, so it is 6.58% V over V. So I don't need to divide by 100 and then I can go back to percent. No, I already have the 100 in denominator, so I just keep it. Okay, so now I can use these numbers. So this is one answer here, which is W over V, V over V. I can use them. Okay, so what is molarity? Okay, what is molarity? Mole per liter. Okay, so what do I have? Do I use the first one or the second one? Okay, if I use the second one, I have top, I have milliliter. How can I go to mole? I can't. So I use the first one. I use the first one because from the first one, which is gram per which is gram over milliliter, I can go to molarity. Okay, so I can go to mole per liter. I can change both of them. How I use molar mass? Okay, so I have 14.2. Again, I use forever because I don't want to use rounded answer. So gram NaCl over 100 milliliter of solution. Okay, so multiple. I want to cancel gram and I want to bring mole. Okay, so molar mass goes down because I want to cancel gram, and mole goes up. Multiple. So milliliter up, 10 power minus 3 liter down. Okay, so now I can cancel. So I can cancel gram and gram. I can cancel, sorry, I need mole. I can cancel milliliter, and then I have the answer. So I have these, I have these, I have these, I have this one, and I have this one. So these numbers are, yes. So I need, let me see, I need, here I need 4 significant digits because I have 1 mole is exact, so 100 is exact, 10 power minus 3 is exact because that's the definition of milliliter. And so yes, I need 4 significant digits I have, and here I have more significant digits, so I round to 4 significant digits. So this 2.4336, I underline that, check that, so which is 2.434 m, okay, which is mole per liter. Okay, 2.434 m. Okay, so that's here. This is the answer. So now here we want to go to W per, just W over W. So for top I am fine. I can use the just the part A. I can use part A and go to so for top I am fine, but for the denominator I need to go to W, but for denominator I have milliliter. Okay, so what should I do here? So here I can zoom in. So we need to find the total in gram for the denominator. Okay, total in gram for denominator, since the top is what I need. Okay, so we have NaCl, which is part in gram. So I can change using density. I can change this to milliliter. Then I can subtract and find how much water I have. And because it's pure water, I consider pure water, I can go to gram pure water. And then I can add this again, add this to gram of NaCl and find total gram of solution. Okay? So based on my knowledge from before when I was a student, I feel mathematically part D, which is now here, and part E, which is after, Mathematically, they are correct. Yes, I can do them. But in reality, no, because I have NaCl as powder. So when I change it using density, when I change it to volume, I cannot be sure that's exactly the volume that I have from NaCl because it's powder. This thing and this method is correct for the next example, or for when you have liquid but not powder, okay? But I'm not sure, so I do it for you mathematically. Mathematically, yes, it's correct, but I feel based on what I know from before, and I was just a student many years ago. I did chemistry, so it can be correct. It cannot be correct because in reality that's powder. Okay, so see here, I do a step by step. So it is, I do have from part A, I do have 14.2 gram of NaCl, okay, over 100 milliliter of solution. Okay, so 100 milliliter of solution. Okay, so for the top I'm okay, I don't need to do any change, but for bottom I need to go to gram. I need to go to gram of total gram of solution. So what should I do? Okay, so here I just keep this in my mind that I have this from part A. Okay, so 14.2 forever gram NaCl. Okay, so I change it to step by step. So I change it to, using density, I change it to milliliter. So density is here. Yes, 2.16 gram of NaCl. Okay, so the answer is 6.58436. Okay, so that's milliliter. Okay, so remember, I don't use my rounded, I don't round and use rounded answer. No, I keep this the whole thing I use, the whole numbers that I see, I use it. So I keep it in my calculator. Okay, so this is milliliter. This is milliliter NaCl. Okay, we can round. Oh my god, what happened? So I don't know what happened here. So I can delete that. All of a sudden it made another file for me. That's crazy. Okay, so I can go back here. Yeah, so 1 second. So it's sometimes it's hard to, yeah, to follow these steps. Okay, so yes, I have to, yes, okay, milliliter. So milliliter of NaCl, milliliter of NaCl. Okay, now okay, so now, so this is first step, this is second step. So third step, okay, third step is here. What can I do here? Okay, every time we have issues here. So here I can find volume of water, volume of pure water. So here 100 milliliter solution minus 6.58436214 milliliter NaCl, and this will be 93.415638786. You can just use several digits, not these too many. Okay, so milliliter of water. Okay, so now we found milliliter of water. Okay, because it's pure water, we can say it is the same as, so 93.41563,786 415,63786 milliliter of water is 93.415,63786 gram of water. Okay, good. So now I have the gram of water here. So now I can say, okay, I have gram of solute, which was from beginning 14.2 forever, and I have now the total. So here the answer is that. So percent W over W is 14.2 forever NaCl divided by 14.2 forever NaCl plus 93.4156786 gram water. Okay, I can add them. Okay, and then I can find the answer. So the answer is, okay, so that's here 415,637. In reality, you don't need those too many digits because you can just use several more. For example, you have to use 3 significant digits, you can use 5, okay? So you don't need to. Okay, so the answer is 0. So 0.13213, okay, which is 13.2. I can do, let me see, I can do 3 significant digits. 13.21, I underline, I check that it is almost 13.2% W over W. Okay, so this is mathematically, but I feel in reality, because it's powder, it doesn't work this way. Okay, so what is part per million? Part per million, remember, part per million, whatever to whatever. So both of them should be the same unit, top and bottom. So here I can use the previous one because both of them are gram. Okay, so X G over 1 million G is 13.213, okay, divided by gram divided by 100 gram, because this is from part D. That's from part D, okay, W over W. So the answer is, X is, so 1.32 multiple 10 power 5 part per million. Okay, now I can do for this example. For this example, it's acetone, and that's liquid. So for this one is so don't be a problem. What I just already explained and said. Okay, so I do I. Okay, so 12. I have 12% W by W. Okay, so I want to go to W by V. W over V. So I start from W. Okay, so I start from this percent W over W means 12 gram acetone over 100 gram solution. Okay, so multiple. I want to go to W per V. So I need to change bottom. I need to change solution. I need to use density of solution in order to go to volume. What is density of solution? Okay, density of solution is here. This is density of solution. Okay, remember, I don't use density of the just acetone. No. Okay, so density of acetone is the other one, 0.7899. So here is 0.9849 gram solution over 1 milliliter solution. Okay, which is 11.8188 gram acetone over 100 milliliter of solution, which I can round it to 11.8 W over V. See, I start from W over W. I don't need to do anything for top. I just change bottom. Okay. Okay, so the next. Okay, the next one. So I need to go V over V, percent V over V. Okay, so do I start from beginning W over W or W over V? I start from W over V because it's easier for me. But I don't start from 11.8 because this is rounded answer. I start from this one. So it is this gram acetone over 100 milliliter solution. Multiple. So I don't need to do anything for top, just bottom. So I use 0.7899, which is density of acetone, and go to 1 milliliter of acetone. Okay. So it is, I cancel this and this. What is left? This one and this one and this one and this one here. This one is left. This one is left. Yes. And this one is left. And this one is left. And this one is left. So what is cancelled here? Just this and that. Okay. So now the answer is 14.9624 milliliter over 100 milliliter of solution. Okay, which is almost 15.0% V over V. The next, molarity. Okay, for molarity, you need to go to mole per liter. So which one you use? You use the first one? No, because it's W over W. The second one, the third one, so no, it's V over V. So I just use W over V. It's easier for me because I can go to using molarity. Okay, so it is 11.8188 gram of acetone, okay, over 100 milliliter of solution, multiple. Okay, so this is part 1, and that's part 2, and that's part 3. I have to see which one I start. Okay, so here, yes, I change milliliter to liter, multiple. I change gram to mole. One mole acetone. Okay, so now okay, what happened here? So gram acetone cancel, milliliter cancel. What is left? Mole and this number, and per liter, and this number, and this number. So it is 2.0349, which is almost 2.03 molarity, capital M. Okay? Yeah. The last but not least is part per million. Part per million. For part per million, I use the first one, which is the weight by weight. Okay? So it is 12. So this is just the last one. 12 gram of acetone over 100 gram of solution. Okay? X over 1 million. Okay, X is 1.20 multiple 10 power 5 part per million. Okay? So, we are done with this lesson here, and you can go and do this practice here, and you can see the solution in this website. So we move to topic 13. We are done with topic 12.